AIM 11.5 Sample Means and Proportions, and your homework tonight is Delta Math. So let's go over some vocabulary. Population. A population is the entire set of subjects in which there is an interest. A sample. Sample is a part of the population from which information or data is gathered, and often with the purpose of generalizing from the sample to the population. So, for example, if your population is very large, you may just only gather information from a sample, which can be indicative of how the whole population is feeling about something. And here's an example. So let's say that candidates in an election wanted to know the potential outcome. They would not sample the entire population, but would conduct surveys with smaller groups. The idea is that these smaller groups would be an indication of how the population would vote. So in the United States, a survey of 2,184 adults ages 18 and over, it found that 1,328 of them owned at least one pet. So these 2,184, that would be considered the sample, while you have the population, which is everyone 18 and over. Okay, so now a population proportion. It is the ratio of members of a population with a particular characteristic to the total members of the population. A sample proportion, or p-hat, is the ratio of members of a sample of the population with a particular characteristic to the total members of the sample. Basically, it's a comparison of the ratio of the smaller sample to the general population. Not every random sample results in the same estimate of a population characteristic. There be some sampling variability. So taking smaller groups, you may not always get the same outcome, but they should be more or less close. You should see a common behavior that emerges. So standard deviation of proportions. For random samples of size n, the standard deviation of the sampling distribution of the sample proportion can be calculated using the following formula: the square root of p times 1 minus p divided by n, where p is the population proportion and n is the sample size. So, the distribution of sample proportions. The distribution of sample proportions, p-hat, from a population with a proportion p and a sample size of n, will have a normal distribution, have a mean and a population proportion p, and have a standard deviation given by the previous formula, the square root of p times 1 minus p over n. So here, however, you do have to identify, when you do stuff like this, potential biases. So here's an example. A Sunnyvale High School Student Council dance committee is trying to decide whether to have a band or DJ for the fall dance. They decided that each of the 4 committee members should survey the students in their homeroom classes. Identify any biases with the sampling method. Well, this would be considered a convenience sample, and that it's convenient for the committee members. It's not necessarily random. Also, 4 homerooms may not accurately reflect the opinions of the entire school, because 4 homerooms is probably a low percentage of all the school's homerooms. This is quite true of places outside of New York City, where they can have, a few thousand kids in their schools. So taking a sample of 4 classes, 4 convenient classes, would not necessarily indicate how the entire school population might feel. Also, it's biased and it's not random. Okay, so proportion inferences from simulations. Here's an example. Nolan rolls the die 100 times and 27 out of the 100 rolls comes up as a 6. He wanted to see how many would likely, so he wanted to see how likely a result of 27, 27 sixes in 100 rolls would be in a fair die. So Nolan used a computer simulation to see the proportion of sixes in 100 rolls repeated 200 times. Based on the results of the simulation, what inference can Nolan make regarding the fairness of the die? Okay, so 27 out of 100. So here's the proportion of those 6 rolls. And each dot here represents the proportion of sixes in 100 rolls of 200 trials. Okay, so here we have this graph that's developed. So for example, when you're looking here, this would represent the 200 trials of a fair die. Not that he actually rolled it or did this trial 200 times. He did it once, and now he's comparing his results to other trials that would be fair to see if his die is in fact fair. Okay, so first thing we need to determine is that the sample proportion here is 0.27. So now we want to highlight the dots with the proportions that are 0.27 or greater. Okay, so you see here that in yellow, it's just these two. Since the simulation shows few cases with a sample proportion of 0.27 or greater, we can conclude that the die is quite possibly not fair. Had the die been fair, the results would have been closer to center of our somewhat normal distribution. However, it's an outlier, and it's unlikely that the initial die used was fair. Okay, so if it was fair, you'd probably see it closer to 0.16 or so, because a sixth of a die is about 0.17%, or sorry, 0.17. Okay. So a second example. There's an upcoming election for student council president at a high school. Candidate A must get over 50% of the vote to be elected. A poll was taken at random of 50 students from the high school, and 27 students said that they would vote for candidate A. Simulations were done, and a population percentage of 50%, with a population percentage of 50% and a sample size of 50, to see how likely a sample of 50 would have 27 who preferred candidate A. The results of 100 simulations were shown below. What conclusion can be drawn regarding the likelihood that candidate A will win the election with more than 50% of the vote? So this is the case of majority rules. So this person wants to see what's his likelihood or her likelihood of getting more than 50% of the vote. So we have to look at the proportion here. So 27 over 50 would land is 0.54. So in this simulation, if you look at those that are 0.54, it's these that are highlighted in yellow. Now, if they had to base their future outcome, will their candidate A win the election or not? We can make the following conclusion. Since the simulation shows many cases with a sample proportion of 0.54 or greater, the results are inconclusive. Notice that it's almost, well, here. Notice how the results are close to the mean, approximately 0.5. This would indicate that there's no indication that the candidate has secured enough votes, because there is a sizable portion here that it could still sway to. You would want the candidate to have a stronger hold. So perhaps being, closer to over here, and then everything that's greater, well, now you've got a much better chance of winning the election. However, at 0.54, it's too close to tell. Okay, so now the differences of means. To test the results of two groups, your control and your experimental, we compare the difference of means. A simulation of the experiment is conducted. The results of the initial trial are compared to the results of the simulation. Based on the results, conclusions about the initial sample can be inferred. So here's the difference of means, group A minus group B.